Hello, I'm Greg Meyer, and in this video I'll present the poster for our paper entitled Efficient Transformer-Based 3D Object Detection with Dynamic Token Halting. This work was done by Mao Yi, myself, Yuning Chai, and Cheng Liu. Recent progress has shown the potential of applying transformers to computer vision tasks. Transformers already meet or exceed the performance of convolutional neural networks. However, they often suffer from high latency due to the quadratic nature of self-attention. In this work, we propose a method for accelerating transformer-based 3D object detectors by dynamically halting tokens based on their usefulness to the detection task. Our method significantly improves the latency versus accuracy Pareto frontier when compared to existing approaches. Our approach is built upon SST, which stands for Single Stride Sparse Transformer. SST is a recent LiDAR-based 3D object detector. The model starts by voxelizing the LiDAR point cloud into bird's eye view pillars, and each voxel is treated as a token by the transformer. Before each layer in the transformer, we add a halting module whose job it is to determine which tokens to keep and which tokens to halt. It does this by predicting a score for each token, and if a token score is below a threshold, it is removed. Halting a token is a non-differentiable operation, so during training we define a pseudogradient to enable backpropagation through the halting module. To improve learning of the halting module, we leverage a weighted self-attention operation, which reduces the attention given to tokens with low scores. The weighted self-attention has important implications on the quality of the pseudogradient. Please refer to the paper for a detailed analysis. After the last layer in the transformer, we recycle the tokens that were halted in the earlier layers and combine them with the tokens that were not halted. We do this because we observe that even though a token is halted early, its features are still useful to inform the final prediction of the model. The whole model is trained end-to-end using a detection and sparsity loss. Instead of using a uniform sparsity loss, we found it beneficial in the early stages of training to use a loss that more significantly penalizes background tokens. To study the efficiency and accuracy trade-off of our method, we vary the level of sparsity of the tokens within the model. We compare our approach to other model scaling techniques, including width scaling and attention head scaling. Also, we adapt AVID, a dynamic token halting approach for image classification. Our method provides the best efficiency and accuracy trade-off. In fact, our method can achieve over a 50% speedup with only a slight impact to performance. Our proposed method can significantly reduce the latency of SST without dramatically impacting its performance. We can reinvest the latency savings to improve the performance of SST while maintaining its runtime. We improve the performance of SST by simply increasing the capacity of the detection head. And in doing so, we obtain state-of-the-art performance on the Waymo Open dataset. In addition, we obtain significant improvement over the original SST without increasing its latency. To better understand the token halting process, we can visualize the tokens halted at different layers with different colors. We observe that most of the tokens belong to roads, buildings, or foliage, which do not contribute much to the detection task. And appropriately, these tokens are halted at the very beginning of the model. Our model tends to keep tokens that are near the objects of interest, since these tokens are usually informative. Lastly, we observe that tokens belonging to objects remain unhalted with a significantly higher chance, as those tokens are in general critical for the detection. In conclusion, we propose an approach to dynamically halt tokens in order to speed up transformer-based 3D object detectors. Our method significantly improves the Pareto frontier of the accuracy and efficiency trade-off. By leveraging our improved model efficiency, we are able to dramatically increase the performance of the model without sacrificing latency. Thanks for watching.